Thank you so much for that kind introduction. It's really a pleasure to be here. Thank you for inviting me. I do want to say I miss seeing my good friends and mentors, Sarah, Marta, and Doug. Honestly, many of the milestones that I experienced in my career, I owe a debt of gratitude to these Princeton giants. I felt like I sort of followed in Sarah's footsteps, and I'm pretty sure she wrote all of my letters for promotion. Marta accepted my article to AJS when I was a first-year assistant professor. You're always very grateful for that. And Doug remained one of my mentors for life. He was actually one of the only advisors at Penn when I was trying to decide whether to go to UNC or Michigan for my job, who said, I could really see you at Carolina. So I followed his intuition, and it's served me well. Okay, so let's see here. Yeah, perfect. Here's what I'm going to talk about: intergenerational mobility and health. Then more specifically, racial and ethnic differences in the health benefits of upward mobility, look at some potential mechanisms, and then end in a more general just topic of social mobility and biological aging. So I think, among the lay population and really many of us, there's sort of a universal assumption that social mobility, upward mobility, should improve health and well-being, operating mainly through the mechanisms of greater access to social and economic resources, especially access to healthcare and healthier lifestyles. But there are three theoretical patterns of physical health effects of upward social mobility in the literature. The first theory suggests that upward mobility will improve health by reversing the effects of early life adversity, primarily economic adversity, compared to those who remain in a lower level of socioeconomic status. A second theory says that the health of those who experience upward mobility will be somewhere between, it'll improve such that it's better than those who remain at low levels of SES, but it'll be, but not quite as good as those who remain persistently in high levels. So it'll be somewhere in between. And then a third theory suggests that the experience of upward mobility will have deleterious effects due to the stress of achievement and loss of social connections. And this theory primarily relates to certain social groups. All right. So there's lots of limitations in this area. Just sort of recently did a review. There's different measures of health. And social mobility is sort of, fundamentally within the discipline of sociology. And so health measures aren't so great often. They're a lot self-reported, and as opposed to some of the more biological or maybe biomedical types of designs, different designs and methods. There's often cross-sectional designs, especially for in the area of diminished health returns to SES by race and ethnicity. So there's, really a substantial literature, and I'll refer to this again, on the fact that we observe these racial and ethnic health gaps at equal levels of socioeconomic status. But much of this research is based on cross-sectional data. And to measure mobility, you need two time points. You need an origin and you need a destination, and then to look at change. And then within some of the traditional mobility methods, there are often countervailing mobility effects within certain groups of mobility, like upward or downward. And those are often masked by these methods. Most of the research also primarily focuses on older adults. It makes sense because chronic disease emerges in late midlife and old age. But the process by which we obtain SES often occurs earlier in the life course during young adulthood in terms of investments of education and career, up through mid-adulthood. So there's really very little research that examines how health is associated with social mobility during this process of attainment. And so that's what I'm going to focus on today. How is social mobility related to health earlier in the adult life course when SES is attained? So not a surprise, I'm going to use data from AdHealth. I think most people know something about it. It's a national cohort of adolescents. They were first interviewed in the mid-90s, and then they've been followed for 25 years, at least to, up to the point where data are available right now. And that's in early midlife or wave 5. AdHealth is known mostly for having a very innovative multi-level design where we collected direct measurements from the family on genetic pairs, romantic diets, friends, peer network, neighborhood, school, and community. It has great racial and ethnic diversity. And what I'm going to do here is examine mobility, so the destination at 2 points in time. In wave 5, when the cohort's in the late 20s, and wave 4, when the cohort is in their late 20s, and it's actually shown right here, and wave 5, when the cohort is in their late 30s. So the origin is early life SES. That's at wave 1. The cohort was between the ages of 11 and 20, then 12, 19 for the most part. And then wave 4, they're in their late 20s, and wave 5, the adult SES will be measured when they're in their late 30s. And so we're focusing on, I'm actually going to show you results from 3 different studies, all related to social mobility. And I should say that, and we measure and model mobility several ways. I'll talk about those. But before I start, I want to say that I'm focusing on upward mobility. So when I say, for the most part, social mobility, I'm thinking about upward mobility, which is going from low SES in childhood, or the origin, to higher SES in adulthood. And when I say social mobility, I'm meaning just intergenerational mobility. We can also study intragenerational mobility in AdHealth, but not today. And I also use the phrase health effects pretty often, and that's just a shortcut for saying the association between mobility and health. So I'm not claiming causal inference here, at least not yet, but you'll see, I make some attempts to go in that direction. Okay, so 3 studies. The first really looks at upward mobility from an early life disadvantage that I measure on a multi-level basis to college completion by the late 20s. And in the late 20s, completing your education is probably the most appropriate measure, since income is not that permanent or stable then. Then I go and use a traditional mobility model where I compare parental and adult child education and income between wave 1 and wave 5. And then I'm going to end with some results from a mobility contrast model. This work is sort of new and preliminary, so I'll be curious to get people's feedback on that, to test for heterogeneous mobility effects, and I'll talk more about what that is. Okay. So just a couple slides and background. This is the longitudinal design of AdHealth. And I'm not going to go into a lot of detail about it, but you can see that the waves 1 through 5, those data are available to this point. And the period and the response rates are there. We had an in-school administration first, and then from the school rosters, we selected adolescents and 1 parent for the prospective cohort that we follow over time. So those blue squares or rectangles, that's the prospective cohort that we follow over time, the ages, response rate, and so on. We interviewed the parent at wave 1, and we also have a recent follow-up of the parent at wave 5. The biomarker data is shown in the green. Hope people can see this okay. Ooh, my later slides are not going to look good. But you can see that we've we've been following, we've collected height and weight across all the waves, and that's really allowed us to track obesity in this cohort, which is actually an extremely important health feature of the AdHealth cohort, because they were born in the late 70s and early 80s, and that was really at the onset of the obesity epidemic in the US. And so that's a very important aspect of this cohort. And then we collected, we started paying attention to what were the most important health conditions at certain life stages. So at wave 3, when they were in their early 20s, we collected saliva and urine and tested for STIs and HIV. And we had an embedded genetic sample in which there were 3,000 pairs of siblings who had some genetic resemblance. So we had identical twins and fraternal twins, and then full sibs, and then half sibs, and then adolescents who lived in the same household but were not related biologically. So we always sort of had this interest in the role of genetics in terms of health and health behavior and AdHealth. And we expanded that over the waves, starting with examining sort of candidate genes at wave 3. And then in wave 4 and wave 5, as more innovative techniques for collecting biospecimens in a field setting developed, we got measures of metabolic, immune, inflammation, cardiovascular. We also collected some medications, and I use a lot of these data in the outcomes. By wave 5, we have a pretty good profile of genomic data, including genotype data, gene expression data, RNA, transcriptome, epigenetic data, and we're in the field now with microbiome. Okay, so that is more or less for background, because I think what I'm going to show you from now on are just going to be these sort of constructed measures sort of based on those types of data. So I use a biosocial conceptual framework that my colleague Tom McDade and I developed, and this emphasizes the multi-level aspects of social context, sort of going in the top panels, from the most proximate to the more distal. And, these obviously operate outside of the body. And then in the bottom panels, we show the biological domains that operate inside the body and in response to environmental influences. And then, of course, this is across the life course. The one advantage of using AdHealth to try to get at what's going on inside the body is that they're still pretty healthy, with the exception of the trends in obesity. So we're able to identify disease risk or health risk before disease is manifest. Okay, and then this gives you sort of an individual sort of perspective of the physiological and the behavioral responses to stressors. So we think about something like social mobility. Upward mobility gives you access to greater resources. You would think that would relieve some of the stressors of dealing with low economic resources when you're trying to maintain your health, whereas downward mobility would be the opposite. So this is a general stress response model. You can see the stressors across the top are the environmental stressors, which are thought of as more chronic daily types of stressors, as opposed to acute stressors of major life events or trauma and abuse. And the notion here, of course, is that exposure to stress activates the stress management system in the brain, which includes the sympathetic nervous system as well as the HPA neuroendocrine systems. And these tell the body to release stress hormones. For the most part, this is good for stress, but the sustained activation in response to chronic or daily stress then can kind of recalibrate the system so that it sort of affects the multiple biological systems involved in the stress response, and throws things off. There can be downregulation of inflammatory genes, increased inflammation, protein, and primarily protein levels, constrict blood vessels, all these things that we feel, heart pumping, pulse raising, storing glucose in case you have to fight off that bear who is chasing you. And then all these things sort of settle down after stress has passed. But when it doesn't, then the system is set off sort of chronically. Now, of course, all of us perceive stress. We have individual differences in that. And the responses are the physiological responses, which I just mentioned, and they can be measured by the biomarkers, but there's also behavioral responses as well. So that's just sort of background, what we kind of think about now. This is the first study, and it's looking at upward mobility from early life disadvantage to college completion. And we're focused on the diminished health returns to socioeconomic status by race and ethnicity. So, as I mentioned, there's a large literature that documents racial disparities in health and longevity. Blacks have higher rates of chronic disease and premature mortality than whites. And what's curious is that this racial gap remains at equal levels of SES. And in fact, the gap is larger at higher levels of SES. So, for example, I can show you here, this is life expectancy at age 25. The solid lines are women, the dashed lines are men, and whites are in black, and blacks are in blue. And basically what you see is each of the sort of column points are levels of education. And at the highest levels of education, college or more, which is the far right, you see that the gaps are quite large. They're also large at high school only, but smaller in between. And here's an example as well that, we find these racial and ethnic gaps in here's a measure of self-rated health, probably my least favorite measure of health, but that's okay. Quite revealing. And, at equal levels of education. Now, this data comes from HRS. So again, this is an older sample. And what you have is the three sets of bars on the left are men. If you can't see that, three sets of bars on the right are for women. And it's white men, Black men, and then Mexican American. Same for women. And then the bars show different levels of education. The light blue bars are the highest level of education, 16 years or more. And what you see here is that all of the light blue bars are higher than, so that self-rated health is higher among those with the most education compared to those with lower levels of education. But the contrast that I wanted to show here is that for whites, at the same level of education, which is 16 years plus, it's always higher for whites than it is for Blacks and Mexican Americans. So this is another, it's an example. This is cross-sectional data, but this gap has been pretty widely documented. Okay, so we asked the question then, why do we observe racial and ethnic gaps in health at equal levels of SES? And perhaps this has to do with the process by which racial and ethnic minorities attain those equal levels of SES. So when young people come from disadvantaged backgrounds and they move up the social ladder, does their health improve? So in this study, we're interested in exploring this notion of skin deep resilience, which comes out of Greg Miller's work with his colleagues, which shows that he uses primarily local samples and primarily of African Americans, but finds that when there is this upward mobility at multiple ages, that mental health of young people improves, but their physical health is sometimes jeopardized. So what we do is we use a multi-level measure of early life disadvantage, based on household data, neighborhood data, and school data. It's like 22 indicators, and then we standardize. We're looking at college completion, 3 racial and ethnic groups. Our mental health outcome is symptoms of depression, and the physical health outcome is metabolic syndrome. And so this came out, and the title actually tells you what we found. College completion predicts lower depression, but higher metabolic syndrome among disadvantaged minorities in young adulthood. Here are the findings for mental health. You can see along the horizontal is our standardized disadvantage index. The CESD is measured as a count, and those with no college degree are the black solid line, and those with college or more is the dashed line. And so you see that sort of across the board, those with college degree or more have fewer symptoms of depression. But for whites, as adolescent disadvantage increases, so do so do symptoms of depression. But for Blacks and Hispanics, as adolescent disadvantage increases, they actually experience lower levels of depression. So they're experiencing a benefit for their mental health. But for the physical health, we find sort of the opposite effect here for Blacks and Hispanics, whereby those who come from disadvantaged backgrounds, complete college, actually experience higher levels of metabolic syndrome, which is an indicator of 5 different biomarkers that is associated with metabolic measures, cardiovascular and metabolic. And so there clearly here is we call it a health cost, that the physical, or you can think of it this way, the physical health benefits of education vary by exposure to disadvantage only for Black and Hispanic youth, that they tend to be worse off. And so we ask, why is that? And, the things that come to mind are that these environmental stressors, what would you experience, what's going on when you're, sort of moving up the social ladder that would be particularly unique to minority young adults, issues like discrimination, social isolation, and cultural incongruence, which is the sense that you don't feel like you fit within your origin, the culture of your origin, society, as well as the destination. So we explored some potential mechanisms. In the paper I just showed, we have pretty good measures of social isolation. We have the degree to which the cohort members are isolated or integrated, one or the other, from friends, family, their peers, and in the community. We have it both in adolescence and adulthood. That was not significant, did not explain this gap that we saw. We have measures of stress. The Cohen self reported stress measure, as well as stressful life events, both in adolescence and adulthood. That didn't seem to do much either. There's this notion of John Henryism, which people might be familiar with, where the notion of striving to get ahead, and the sort of effortful coping takes a toll on your body, just like it did on John Henry, with some measures of perseverance and striving, all of those non-significant. But we did seem to make a little bit of headway with college characteristics. So, and I'm going to show you some preliminary results that looked promising, and then our full-blown effect to try to explain this. So what this shows is we pulled together here the Black and Hispanic respondents, the no college degree people are in there. Then we broke up those who went to college according to whether or not they went to a majority white college, which is the dotted line, blue, or a majority minority, which is the red dash line. And you can see that when Black and Hispanic respondents attended a college that was majority white, that there's a more rapid upward slope toward poor health, this time measured as a cardiometabolic score. This just adds in a couple extra biomarkers, primarily inflammation and inflammation markers of CRP, and another cholesterol measure. We find the same sort of thing with the college characteristic of the selectivity of the college, sort of measured by the rankings from various organizations. And again, when Black and Hispanic respondents attend more highly selective schools, the health costs seem to be a little bit higher. Now, I said this is preliminary because we collected the name of the college where the adult respondents attended at wave 3 and wave 4. And we had only coded up the wave 3 data. Wave 3, they're in the early 20s, but then at wave 4, they're in the late 20s, and they report on the college. So we get more people. So when we add in all of the college characteristics, here they are. This shows you the distribution of college characteristics by institution type. So this tells you that, well, let me backtrack. There are 9 characteristics that we looked at, and it's difficult. We can sort of do this one at a time, but you really want to try to characterize the college context according to these characteristics. And so we did that according to the quality, the student composition, and the resources. We used a clustering approach, and we came up with 3 categories of the college context: an average, an advantage, and an elite. These are the characteristics, and you can see the distributions here across these types of colleges. So we have endowments and expenditures, graduation rate, mobility rate. That's the Chetty mobility rate that we also merged in. The rejection rate, SATs, percent of students from families in the top 1%, percent of white students, and then the percent of students with no financial aid. And for the most part, the distributions are pretty much what you would expect for an average versus an elite. I hope people can see that. The mobility rate's the only one that doesn't, really show that much variation across these types. And we've got a smaller sample size because we are limiting this now to college graduates. So what we do here is, keep an eye on time. This is tricky, right? Because we know that there is certainly selection into these college types, and that selection also would vary by race and ethnicity. So we do the best that we can to try to get at the selection. And actually, we can do really pretty well with observed characteristics because we have a ton of characteristics in terms of the adolescent, the GPA, cognitive ability, belief in hard work. This is just some of them here: school performance, and then of course their health and health behavior, multiple levels, multiple measures of family SES and neighborhood disadvantage. And then we also have information about the schools that they went to. So we have a lot in terms of pre-college characteristics, the secondary school context. We have information from the school in terms of teacher-student ratio, expenditures in the district, graduation rate, percent to go on to college, testing at grade level, so on. And so, that's one of the first approaches that we use. And then we also use the technique, we also use inverse probability, treatment weights, and then school fixed effects. And fortunately, actually, they all come out, that we don't see a lot of difference, even with the school fixed effects. Okay, so what do we find? Do they help explain the high health costs? So first of all, graduation from advantaged colleges is associated with lower cardiometabolic risks. So no surprise there. But we find that in the pooled models, so everybody together, that it's largely explained by selection, those selection characteristics I just talked about. And we also find that the selection is actually stronger for whites and Hispanics. They look similar. But the selection does not explain the Black-white gap in health returns to college completion. So then in stratified models, what we find is that the selection completely explains the health benefits of college type for whites. And so that was probably what was driving the pooled results as well. But when we control for selection among Blacks, we find that there is this health cost that remains for those who attend elite colleges. And this is what it looks like. So what you see here are, the different race and ethnic groups, and then the bars for an average, advantage, and elite. And, as whites and Hispanics attend elite schools, their cardiometabolic risk is lower, but for Blacks, it increases. And this is a significant effect that has remained in all of our models. So we've done some explaining, but we still find this effect we still find this sort of health cost associated with African-American students. And it probably has something to do with the context of the college that they attend. Okay, I was rushing through that so I could get to this part, because now I'm going to bring in a different outcome called biological aging. And now I also, want to know, this is really interesting findings that intrigued us, and tried to figure out, what was going on to explain that relationship. But now we want to look at wave 5. 10 years later, they're in their average age 38, and see if this relationship is still there. So in wave 5, we collected venous blood for the first time. And so we were able to assay for epigenetic data. And we used the EPIC bead chip. We ended up with about 45, almost 4,600 who have epigenetic data. And we calculated clocks measures. We generated epigenetic age and age acceleration from the DNA methylation clock. And we've got, I'm not sure how familiar people are with these, but I can take questions afterwards. I'm not going to explain them very well. We've got a first generation clock, which is the Horvath measure that predicts age. Second generation clocks are the Grimm age and the Pheno age. And those are predicting morbidity and mortality. And then a third generation clock is this Dunedin pace measure, which is actually a rate. It's the rate of change in biological aging. So these are the main measures we use, but what we're really interested in is this epigenetic age acceleration, which is the discrepancy between your epigenetic age. So epigenetic age is your biological age, the aging of the inside of your biological systems, and chronological age. And then that gives you a rate of biological aging. So it's a really nice kind of intuitive measure to look at, especially for aging. And I thought I'd keep an eye on the time. So for questions, I thought I'd show you what some of these look like, just sort of descriptively. So this is showing the mean epigenetic age for Grimm age by education and income and across race ethnicity. And you can see that the age here is, now all the clocks have different levels of, different measures of age, which depends on a number of various things in terms of, what the clock was, the population in which it was trained. But here you can see the range is about 50. Now we know the adult sample is in their late 30s. So why would the biological age be so high? I don't know. I mean, the other one, the Pheno age, predicts ages of 30. So they're somewhere in between. This would make more sense in my view because of the level, the prevalence of obesity in the sample. But if you look within race down SES, you can see that those with less education have a higher biological age, and that's pretty much consistent across the race and ethnic groups. And that looks the same for education as it does for household income. And in fact, the range is really greater across SES than it is across race ethnicity. The white, Black, Hispanic, and I'm showing Asian here. We don't actually analyze Asian because our sample size is still pretty small. But you can see that that Blacks have a somewhat higher biological age than whites. Hispanics are a little bit in between. This can also be seen here. This is basically the same thing, but it's showing the difference in years between those with the lowest education and those with the highest education. But again, as you move from left to right, you're going to lower levels of education, and you can see that that the predicted, now this is predicting the accelerated age. So you can see that aging, that the rate of a biological aging goes up, right, with less education. Again, pretty consistent across the board. Hispanics are always looking a little different. This is education, this is income. It's almost exactly the same. Okay, so in this second analysis here, we're going to do a sort of traditional model of mobility. I'm going to compare the adult and the parents, and then the adult child's education and income between waves 1 and wave 5. And we're just going to use a simple cut for education, college, less than college or college plus. And then for income, we just really use the median, the respective median at wave 1 and the median at wave 5. And then we convert those to $2017. And again, we're mainly interested in upward mobility. So we're really still motivated by what we found at wave 4 to see, are we going to find this at wave 5? So what I show here is just the mobility results. And this is pretty simple at this point. I'm only controlling for age, race, ethnicity, and sex at birth. And what you can see across where the orange row is that moving from the upward mobility, going from low to high, results in a negative coefficient. So that means that's slowing biological age relative to chronological age. And that's pretty consistent across the clock. So I've got the pheno age, Grimm age, the Dunedin pace, which is actually measured in standard deviation units. And just for validation, I put in an allostatic load measure, which combines 10 of the biomarkers. So it's pretty consistent across the board. It's also important to see the high, those remaining persistently at high levels of SES. They have the slowest biological age. And it's even easier to see it here. So now I'm predicting the Grimm age acceleration. And for these 4 educational groups, the second one is low high. That's the upward mobility. We see that that experiencing upward mobility actually slows biological aging. The low experiencing immobility at the low levels means that they're experiencing a faster rate of biological aging. And the upper mobility, the low high, is almost the same as high here. And the other thing that's interesting is that if high is sort of in any of these mobility patterns, that's always better than low. Okay. You'll see why that's kind of relevant. Here are the race and ethnic differences. And so what we find for the race and ethnic differences is the same pattern. And honestly, I didn't think I was going to find this, but it's very consistent. It's consistent across the clocks. Here I'm showing the Grimm age. And again, those in the low-high category have slower have a lower biological age than the chronological age, a slower biological aging. And that's true for whites, for Blacks, and Hispanics. All of the levels of biological aging actually are lower for Hispanics, so that's something that we'll, probably look into in the future. Yeah, so we're not seeing a health cost to upward mobility for Black or Hispanics here in the late 30s. Okay, so the third sort of study, so we thought, okay, that's interesting. So I wonder, now what would be interesting is we know that the mobility process involves an origin, a destination, and a pattern of change or no change, or a process of mobility. And so we thought, well, let's try these mobility contrast models. Are pretty new. We followed the just came out of the ASR article that Lou wrote, and that gives us the ability to improve on some of the prior methods. When you're trying to understand these three components of mobility, you're faced with the same problem as the age period cohort effect, that that if you know any two, then the third is determined. They're all determined, and there's methods of getting around that that have already sort of been out there. But the advantage of this method is that not only can you estimate the simultaneous effects, but in some of the mobility groups, like upward mobility, you might find that, or like, especially I think with income is easier to conceptualize, that upward mobility and income, that you might have a different effect on health if it's at the low end of income as compared to the high end of incomes. If you're going from poverty, $25,000 for a household, to 50, doubling it, that those effects on health are going to be probably greater than if you're moving from 200,000 to 250,000. So, and sometimes they cancel each other out. And so this method allows you to sort of get at that heterogeneity. So what we've done is we used the same parental adult-child educational and income comparison. And rather than just using the two categories, we break it up into terciles of low, medium, high. And then what the estimates then tell us what the importance is of the role of the origin in childhood, the role of the destination, and then the specific pattern. And so here's the results. I'm just going to show you what these results look like, and then I'll finish up. So, you're not going to be able to see these, but very well. Sorry about that. But what I'm showing here is this is epigenetic age acceleration for the pheno age acceleration, Grimm age acceleration, and the Dunedin pace measure. The origin here, this is education. So we've got three categories: high school, some college, same for destination, same for immobile, and then upward and downward then allows these separate pathways. And here we're controlling for, again, just straightforward, trying to understand patterns, age, sex, race, ethnicity. And then we did add smoking status, which is important to control for, and a mother's polyepigenetic smoking score. And then we also look at cell composition. In some models, it doesn't seem to make that much of a difference. And then, so what I'm, what's in the blue bar here is, these, I know you can't see it very well. These are the, our main findings. And you can see how, this nice sort of pattern, that you see consistently for the phenotype, the Grimm age, is an even pace for the destination effects, and same for the immobile. We don't find any significant effects of mobility. Just a little bit of a bummer. And there's a suggestion there might be some origin effects here. But one reason why you sort of do this on multiple clocks is because you're looking for that robustness across the clocks, given some of the differences in their construction. So basically, the interpretation here is that, regardless of origin, Those with only a high school education in adulthood have faster aging. It's about a year older. Look along the bottom here. This again, this is telling you, the distance from, this is the number of years over chronological age that you're aging, and about 1.6 years older for grim age than chronological age, whereas having a college education in adulthood slows aging by about 1.5 years slower for the grim age relative to chronological age. And then the immobility effects, you're getting sort of some of those same different derivations from chronological age, but I sort of interpret these as just standard social stratification findings, or the reproduction of inequality. All right, let me show, I think, just 2 more slides here. This is income. Not much to say except that very consistent. Same destination, most important, immobility. And there might be an origin effect for grim age for high. And then now this is the race and ethnic differences. And we were really, again, hoping for some mobility effects, but we find the same consistent effects of destination and immobility that operate the same for each of the racial and ethnic groups. I think some of the origin effects that we were seeing are seem to be there for whites. Right. So let me conclude so I can take some questions. So, we're not finding a health cost associated with upward mobility for the racial and ethnic minorities when the AdHealth cohort is in early midlife. The destination is more important than the origin, and the mobility process in relation to biological aging. So in biological age, in adulthood, then seems to be more strongly determined by the contemporary SAS markers versus early life markers. I mean, I think if that's true, we have a lot more testing to do. Clearly, that would be an important finding. We find some origin effects for whites, traditional social strat, for the immobile. And again, these findings really hold by race and ethnicity. So I mean, one of the things that we now need to sort of think about, I mean, these are pretty new, last couple of weeks findings, is so what happens then between the late 20s and the late 30s? Perhaps there is some benefit that Black and Hispanic young people experience by settling more into their careers and getting the income that can reverse some of the maybe the health effects that were going on in terms of the achievement of that SES. So let's see, sample size smaller for biological aging analysis. We're missing parental income. That's where our income goes down. And the source of missingness is there's 2 sources. So it's not quite as straightforward to address because some of the parents did not take the parental interview at wave 1, and so they didn't report their income, and then other parents just were non-responsive. And we only have 1 measurement of biological aging. So I think that's really, if we can get the repeated measure, that's going to help us in terms of looking at mobility. And then there's the next steps here. Gosh, there's a lot to look at in terms of mobility. Occupational mobility would be tricky for women. We could create an SES index. We already have one from wave 1. Neighborhood mobility. And of course, there's a lot of opportunity for intergenerational as well between wave 4 and wave 5. We could also look at change in biomarkers then as well. We need to model the selection into mobility, and then really explore the mechanisms, which, like we did for the findings that we got from wave 4, and really try to understand, what changes between the late 20s and late 30s might be occurring to potentially ameliorate some of these health costs of upward mobility that we saw. So I will end there and just acknowledge my co-authors and in all this work and the grants. Thanks very much.